Hello everyone, welcome to the next assignment on network analysis. Here the some problems which is based on the network theorems. So this problem is taken from the Shom series. In the Shom series it is given as replace the active network between terminal AB with the Thevenin's equivalent circuit. So we have to determine the Thevenin's equivalent circuit between terminal AB. It is just like a bridge. So if we redraw this circuit, this will look like a bridge. So what is the current flowing through galvanometers? Just like that. So we have to calculate the voltage across AB and equivalent resistance across AB to determine the Thevenin's equivalent circuit. First, we will determine the Thevenin's equivalent impedance. To determine the Thevenin's equivalent impedance, first voltage source should be replaced by internal resistance. Internal resistance is not given, so voltage source is replaced by a short circuited link. So I will transfer this short circuited link at the middle. Nothing is to be changed. I will transfer this short circuited link at the middle. Take this terminal out, A terminal outside and B terminal outside like here. Short circuited link is transferred in the middle. A terminal is taken outside, B terminal is also taken outside. I will call this as a Z1, this is a Z2, this is a Z3 and this is a Z4. Z1 is 21, Z2 is 12 plus J24, Z3 is 50 and Z4 is 30 plus J60. So if we look this into diagram, if these 2 points are the equipotential points, so this line is can be compressed as a point. This line can be compressed as a point as there is no element in between. So these are the two equipotential points. So these 2 points are compressed together, then it can be easily observed that Z1 and Z2 will come in parallel and Z3 and Z4 will come in parallel. So what is the Thevenin's equivalent circuit? Z1 parallel with Z2 plus Z3 parallel with Z4. These two are in parallel, these two are in parallel, and these all are in series. This is in series with this. Okay. So Z1 Z2 divided by Z1 plus Z2 plus Z3 Z4 divided by Z3 plus Z4. Substituting the value of Z1 Z2 Z3 Z4, we will calculate the value of ZTH. That ZTH comes to 47.34 at an angle of minus 26.81. This is nothing but the Thevenin's equivalent circuit between point A and B. Next we will calculate the Thevenin's equivalent voltage. So this, if we clearly observe that this branch is in parallel with this branch, so means these two branches are in parallel across the voltage source now. So to calculate the Thevenin's equivalence voltage between A and B, it is necessary to determine the potential of VA and potential of VB. Consider this circuit is not there. Suppose this is not there. So this is simple series circuit and we have to determine the potential difference VA. So how VA is calculated? Voltage drop across 12 plus J24 is nothing but the voltage VA. So how will calculate voltage drop across J plus 24? When J plus 24 is to be calculated, that is taken into numerator 12 plus J24 divided by sum of this 21 plus 12 plus J24. So 21 plus 12, it gives you 33, 30 plus J24 into total voltage source is 20 at an angle of 0. So this is a 20 at an angle of 0. So it gives you the VA voltage. Similarly, how will calculate the VB potential? VB potential. In this VB potential, if we observe, so consider this branch is not there. So if this branch is not there, this is nothing but a series circuit. 50 is in series with the 30 plus J60. So I want to calculate VB, that is the potential across 30 plus J60. So 30 plus J40. Sorry, by mistake I have taken this in this problem it as a J40. It should be J60. Okay, so it should be J60. So make it correct, please. It is a J60. So 50 plus 30, it gives you 30 ohm and it is J60. It is not a J40, it is a J60. So 80 plus J40. So 80 plus J40, not a J40, it is a J60 into 20 at an angle of 0. So what is a VTH? VTH nothing but VA minus VB. So VA minus VB, 12 plus J24, that is this is the voltage VA minus voltage VB. If we calculate this, will give you 0.38 at an angle of 170.5. 0.38 at an angle of 170.5. This answer may be differ because I have taken by mistakenly I have taken it as a 40. It should be J60 here. Okay, so that the answer may be differ from this, but this is the process to calculate the calculate the Thevenin's equivalent circuit. Let's have a second problem. In the second problem, two series elements are given. Two series element, voltage across that series element is 240 at an angle of 0 and current carried by it is 50 at an angle of minus 60. Determine the current which results when the resistance is reduced. Means whatever the impedance is connected, out of that resistance is reduced to 230%. It is not by, it is 230%, reduced to 230%, and 60% of its former value. First we will calculate the impedance of the circuit. How will calculate impedance? Total voltage and current is known. So V divided by 240 divided by 50 at an angle of 60. So current is 4.8 at an angle of 60 degree, that is 2.4 J 4.16 ohm. So if we this is the total Z. It is in rectangular form, it is in polar form. I have converted into polar rectangular form because I want to reduce the resistance only. So in first case the resistance is reduced to 30%, not by, it is to 30%. Hence 2.4 into 0.3. So 2.4 into 0.3, resistance is 0.472. But see the reactance was J 4.16. J 4.16 is as it is. So this is my new impedance. So new current is equal to V divided by Z new, 240 divided by 0.72 plus J 4.16. This gives me 56.85 at an angle of minus 80.80. Similarly, resistance is reduced to 60%. It means 2.4 into 60 plus J 4.16. The reactance remains same, only resistance is reduced. So when then new current will be 54.51 at an angle of minus 70.91. Okay, suppose in this problem it is given instead of 2, by is given, reduced by 30%. Reduced by 30% means new value will be 2.4 into 0.7, because 30% is reduced, so 0.7. 60% means 2.4 into 0.4 it must be taken if it is given by, but it is given 2. So look the words carefully when solving the problem. Let us have a next problem. We want to determine maximum power passing through the AB terminal. I have to connect the load between AB such that the power delivered by this source is maximum. Hence it is the problem of maximum power transfer theorem. To determine the maximum power, must be necessary to calculate the Thevenin's equivalent circuit. So how will calculate the Thevenin's equivalent voltage? That is voltage between AB is nothing but the voltage drop across 5 plus J10. So 5 plus J10 divided by 10, 5 plus 5, that is 10 plus J10. So into total voltage source is 100 at an angle of 30. So VTH is coming to be 79.06 at an angle of 48.33. This is my VTH. Now I want to calculate ZTH. To calculate the ZTH, voltage source is considered as a short circuited, and looking from this terminal AB, if we look from the terminal AB, 5 ohm, as it is shorted, 5 ohm is in parallel with 5 plus J10. So 5 into 5 plus J10 divided by 5 plus 5, that is 10 plus J10. So hence equivalent Thevenin's impedance is 3.74 plus J 1.25 ohm. But for the maximum power transfer, what is the condition for maximum power transfer? The load between AB, that is ZAB, that is this load impedance, must be complex conjugate of Thevenin's equivalent impedance. So complex conjugate of Thevenin's equivalent impedance, that is 3.75 plus J 1.25, which is the Thevenin's equivalent impedance. The conjugate of that, if we take the conjugate, we have to change the sign of J. So J, previously J is plus J, now it should be minus J. So this should be the ZL which is connected. Then what is the maximum power transfer? Maximum power transfer is always equal to VTH square upon 4 RTH. So VTH is 79.06 square divided by 4 into what is the value of RTH? RTH is, that is resistance is 3.75. So 3.75. So that comes to 416.7 watt. So by this way we can apply the theorem for solving the problem. Thank you.